Many users default to VMware Workstation or Oracle VirtualBox for local virtualization tasks, perhaps overlooking the robust tool already available in their system, Windows Hyper-V. It's worth noting that Hyper-V, integrated into both Windows 11 and Windows 10, shares the same underlying virtualization technology as its Windows Server counterpart. While Hyper-V and Windows Server boast advanced features suited for enterprise settings like failover clustering, sophisticated networking, and shielded VMs for heightened security, the core functionality for creating, managing, and running virtual machines remains consistent. To run Hyper-V, ensure your computer's processor has second-level address translation and includes hardware virtualization support, specifically Intel VT-X or AMD-V, and that this feature is activated in your system's BIOS UEFI settings. Also, you must have Windows Professional, Professional for Workstation, Enterprise, or Education. The home editions of Windows 11 and Windows 10 do not include Hyper-V functionality. You can verify hardware compatibility by opening a PowerShell session and using the get-wmiobject commandlet. The virtualization firmware enabled and second-level address translation extensions properties for each physical processor will have true values. Installation is straightforward. First, close any applications and open files. Click Start, Settings, Apps, and Optional Features. Scroll down to More Windows Features. Expand and check the Hyper-V box. Ensure all items are selected. Click OK. When prompted, click Restart Now. The process will take a few minutes, and the computer may reboot a couple times. Likewise, from an administrative PowerShell session, you can install all of the Hyper-V components with the Enable Windows Optional Feature commandlet or the DISM command. When prompted, depress the Y key to restart. Click Start and type Hyper-V. Click Hyper-V Manager. Your computer should be listed as a host. Right-click your computer name and select Hyper-V Settings. By default, virtual machines and virtual disks are stored in these predefined folders. While you can designate custom folders while creating a virtual machine, it's also possible to alter the default storage paths to new locations, such as external drives or network-attached storage. The virtual machine storage location contains these virtual machine configuration files. The virtual hard disk is the location of the VHDX file. The enhanced session mode allows an RDP-like connection to the virtual machine and supports redirection of host-attached peripherals. Close Hyper-V Settings. Right-click your computer name again and select Virtual Switch Manager. Think of this in the same manner as you would physical switches. An external switch binds to a physical network adapter and allows the VM to access the outside in the same manner as the host. If you have multiple NICs, you can have an external adapter bound to each one, even your wireless. An internal switch is a semi-private network enabling virtual machines to communicate with each other and the host system. This setup facilitates isolated network among VMs while still allowing interaction with the host. A private switch allows virtual machines on the same host to communicate exclusively with each other. This setup isolates them from the external network. However, a VM can act as a router to route traffic from a private switch to an external network. We'll cover the router in a later video. Here, we're going to create a private switch. With private selected, click Create Virtual Switch. Provide a meaningful name and click Apply. Notice there is a default switch. This is automatically created to allow the Windows host to act as a NAT to the underlying VMs. This default switch is unique to Windows 11 and Windows 10 clients and is not available in the Hyper-V implementation on Windows Server. The Hyper-V default switch is represented as the Ethernet adapter vEthernet default switch when ipconfig is invoked. The adapter is a /20 network. However, it is not shown in the Network Connections window nor reflected with the get-netadapter commandlet. You can have as many external, internal, and private switches as needed. To create a virtual machine, click Start, type Hyper, and open Hyper-V Manager, which is the primary tool used to create and modify virtual machines. Right-click the computer name, click New, select Virtual Machine, and click Next. Provide a meaningful name for the virtual machine. If desired or necessary, you can select a different location for the virtual machine. Here, I'm going to store the VM in the V drive under the folder virtual_machines. Specify the virtual machine's generation. A Generation 1 virtual machine is analogous to an older BIOS-based physical computer and may be required for some older operating systems. A Generation 2 virtual machine is analogous to a newer UEFI-based physical computer and is preferred for all current modern operating systems. Assign memory. For this example, I'm going to leave dynamic memory checked and enter 8192 megabytes, which is 8 gigabytes. For networking, we select the desired virtual switch we created earlier. Here, I'm going to select the default switch. For the virtual disk, we can accept the default location based on the location of the virtual machine or select another location. For our demonstration, I'm going to select a folder on a 12 terabyte disk that is mounted to an NTFS folder. The default disk size for new virtual machines is 127 gigabytes. However, I'm going to change the capacity to 320 gigabytes. Now we select the bootable ISO file for our chosen operating system. At the summary screen, verify your choices and click Finish. The Hyper-V Manager that ships with Windows 10 and Windows 11 provides a quick create feature that is not available with the Hyper-V that ships with Windows Server. Click Quick Create. The operating systems listed here are provided by the Microsoft Windows Store, similar to how it provides the Windows Subsystem for Linux, WSL, distributions. Check my videos on installing and configuring WSL. You can also select an ISO OS installation file or current virtual disk by clicking the local installation source link, followed by the Change Installation Source button. Click the File Type dropdown to see compatible sources. Although the virtual machine is ready, we need to modify some settings after it is created. Right-click the virtual machine and select Settings. At the hardware top level, under the Add Hardware heading, we can add an additional SCSI controller or network adapter if necessary. Under the Security heading, for some Linux distributions, change the Secure Boot template to Microsoft UEFI Certificate Authority. For some other operating systems, the Secure Boot checkbox may need to be unchecked. Check Enable Trusted Platform Module. For Windows 11, this is a requirement. Under the Memory heading, when using dynamic memory, I like to change the buffer from 20% to 50%. This is optional. For this example, I'm limiting the maximum RAM to 16 gigabytes. Under the Processor heading, I'm leaving the number of virtual processors at 4. Under the Network Adapter heading, we can change our virtual switch and assign a VLAN ID if necessary. At the Management top level, under the Checkpoints heading, we can modify our checkpoint types and the checkpoint file location. For this example, I'm going to uncheck Automatic Checkpoints. Under the Automatic Start Action and Automatic Stop Action headings, select the desired action items. When finished, click Apply, followed by OK to accept all modifications. Using the same virtual machine specifications and settings as earlier, we can also create and configure a virtual machine using PowerShell. These commands also work with Hyper-V on Windows Server and Windows Server Core. Click Start and open an administrative terminal or PowerShell session. First, set a variable for the new virtual machine name. Create the new virtual machine. Set the number of virtual processors and maximum memory since we're using dynamic memory. Optionally, set the memory buffer. Enable Secure Boot. Enable TPM, which is a requirement for Windows 11 guests. However, it is not necessary for some other operating systems. Add a virtual DVD drive and attach an OS installation ISO file. Set the virtual DVD drive as the first boot device when setting up a new VM using an ISO installation file. Enable nested virtualization, where a virtual machine can host other virtual machines. You can verify the settings using Hyper-V Manager. On Windows 10, Windows 11, and Windows Server, we can use the Windows Admin Center to create and manage virtual machines. I'll cover the installation and configuration of the Windows Admin Center in a future video. With Windows Admin Center open, click your host machine. In the left pane, scroll down and select Virtual Machines. Under Inventory, click Add, followed by New. In the right pane, provide a meaningful name, select the generation, select the virtual machine location if desired. Again, I'm going to select the Virtual Machines folder on the V drive. For the processor count, I'm going to select 4 virtual CPUs. Select Startup Memory and check the Use Dynamic Memory checkbox. Select the virtual switch. Again, I am selecting the default switch and leaving the isolation mode to None, which is basically not setting a VLAN ID. If you want the virtual disk co-located with the virtual machine, click the plus add under Storage. In this example, We're going to add the virtual disk later. Click Create. You may have to click the refresh button to see the new VM. Since I want to store the virtual disk in a location separate from the virtual machine, I have to create the disk after the VM is created. Select the virtual machine and select Settings. Under Disks, select plus Add Disk and click New Virtual Disk. In the right pane, we can now select a custom path. Click plus Add again. Select the path to the bootable ISO file. Click Save Disk Settings. Click Boot Order and move the DVD with the attached ISO file to the top. Click Save Boot Order. Click Checkpoints and make any desired changes. Here, I'm going to uncheck Automatic Checkpoints. Click Save Checkpoint Settings. Since I am creating an Ubuntu Linux virtual machine, I am selecting Microsoft UEFI Certificate Authority for the Secure Boot template and leaving the Enable Trusted Platform module checkbox unchecked. Save Settings and click Close. In Hyper-V Manager, right-click the virtual machine and select Connect, which launches the virtual machine connection interface. Click Start. If the Display Configuration dialog appears, click the Connect button for an enhanced session, which is similar to a rich remote desktop connection. Closing the dialog by clicking the X results in a standard session, which is similar to a direct console connection. A couple of things to note. Under the Action menu, Turn Off is abrupt and is like pulling the virtual electrical plug. Shutdown is a graceful, controlled shutdown that allows the operating system and applications to terminate normally. Under the View menu, we can choose between the standard or enhanced sessions. Under the File menu, Settings, we can take the following actions while the virtual machine is running. Add an additional network adapter. Change the network adapter virtual switch, VLAN ID, or institute bandwidth management. Increase the maximum RAM if dynamic memory is enabled. Add an additional virtual hard drive. Change an existing virtual hard drive. Add an additional DVD drive. Change the DVD drive ISO file. Remove an added virtual hard drive, DVD drive, or network adapter. Depending on the guest running operating system, some features under the menu items may be unavailable. The virtual machine connection interface has to be used when interactively setting up a new virtual machine. At an administrative terminal or PowerShell session, open the virtual machine connection by typing vmconnect.exe. In the virtual machine dropdown, select the desired VM, click OK, and click Start. To start a VM and bypass the VM Connect selection dialog, use the Start-VM commandlet followed by VM Connect. At the Virtual Machines page, under Inventory, select the virtual machine. Click Power followed by Start. Use the Windows Admin Center to start a virtual machine only after guest operating system is operational. The host system used for this demonstration is a virtual machine with nested virtualization enabled running on a Windows Server 2025 Hyper-V host that is installed on a Dell Precision workstation with 16 CPU cores and 144 gigabytes of RAM. I hope you enjoyed this video, learned something new, and found it useful. If you have any feedback, corrections, or suggestions, please let me know in the comments below. Please like, subscribe, and pass it on to others. And I thank you for watching.